Okay, let's consider the following questions on Coulomb's law. 2-point charge Q1 equals to 2.0 times 10 raised to the power of negative 5 Coulomb, and Q2 equals to 4.0 times 10 raised to the power of negative 5 Coulomb are separated by a distance of 0.5 meter. Calculate the electrostatic force between them. Okay, let's start by writing out the parameters that were given in the question. We are given that 2-point charges Q1 equals to 2.0 times 10 raised to the power of negative 5 Coulomb. So the first parameter there is Q1. Q1 is 2.0 times 10 raised to the power of negative 5, and the second charge is 4.0 times 10 raised to the power of negative 5 as well. And these charges are separated by a distance 0.5 meter. So R is 0.5 meter. Okay, we are asked to calculate the electrostatic force. So we are looking for F. Now don't forget that I gave you a formula. F equals to K Q1 multiplied by Q2 all over R squared. Do you remember? This is the formula for the with respect to Coulomb's law. This is the formula that we have, where K is the Coulomb's constant, and I told you that K, Coulomb's constant, equals to 9.0 times 10 raised to the power of 9 Newton meter squared per Coulomb squared. Do you know? So, with respect to the formula that we have on the board, we can easily calculate the force of attraction between these 2-point charge. Okay, just replace the value of, okay, let's go. F equals to K. K is 9.0 times 10, so I'm going to have 9.0 times 10 raised to the power of 9 multiplied by Q1. Q1 is 2.0 times 10 raised to the power of negative 5. So I'm going to have 2.0 times 10 raised to the power of negative 5 multiplied by Q2. Q2 is what? 4.0 times 10 raised to the power of negative 5. So I'm going to have 4.0 times 10 raised to the power of negative 5 all over 0.5 squared. I mean 0.5, yes. 0.5 squared. Okay, so F equals to, now please pay attention, when you are taking the product of this, 9 times 2 times 4. 9 times 2 is 18. Are you getting it? 18 times 4 will give you 72. You understand? So you're going to have 72. Please pay attention. 72 multiplied by now 10. Do you know how I did it? Just take the product of this, and this. So we have 72. Now take the product of 10 raised to the power of 9, 10 raised to the power of negative 5, 10 raised to the power of negative 5. That is 10 raised to the power of 9 multiplied by 10 raised to the power of negative 5, 10 raised to the power of negative 5. Okay, 10 raised to the power of 9. Now according to the law of indices, 10 raised to the power of negative 5 is 10 raised to the power of negative 10, you know, because we are going to sum this and this together. Negative 5 plus negative 5. That is negative 5, negative 5. That is what? Minus 10. So 10 raised to the power of 9 times 10 raised to the power of negative 10. That is what? 10 raised to the power of negative 1. Because 9 minus 10 will give us what? Negative 1. So I'm going to have negative 1 all over 0.5 squared. 0.5 times 0.5 will give you 0.25. So I'm going to have here will be 0.25. Okay, so with respect to what we have on the board, 72 times 10 raised to the power of 1 divided by 0.25. That is what? 28.8 Newton. You understand? Okay, and if you want to do it another way, just write it 72 all over 10 divided by 0.25. 72 divided by 10 is what? 7.2, right? 7.2 over 0.25. Okay, if you punch your calculator, you're going to have 28.8 Newton. You understand? Okay, let's proceed to the next question. A positive charge of 1.5 times 10 raised to the power of negative 4 Coulomb is placed 0.2 meter away from a negative charge of negative 2.5 times 10 raised to the power of negative 4 Coulomb. What is the magnitude and direction of the electrostatic force between the charges? Okay, We are looking for the magnitude and direction. Now, listen to me. Let's start by writing out the information that we are given in the question. A positive charge of 1.5 times 10 raised to the power of negative 4. So the first charge, solution. So the first charge, Q1, is what? 1.5 times 10 raised to the power of negative 4 Coulomb is placed 0.2 meter. So that means that the distance between the first charge and the second charge is what? 0.2 meters. So R here is 0.2. Now listen to me carefully. There are some instances. That you are going to be given the distance between this charge in another unit, maybe in centimeter. You have to convert to meter. Do you understand? So make sure you pay attention to that. If this 0.2 is given in centimeter, I will have to convert in meter. I will have to convert it to meter. Do you understand? So because it is in meter, so there is no need for conversion. I just emphasize on that because there are some questions you might come across. Don't use the unit. Don't use the value directly.
To watch the complete class, kindly click on the link in the description of this video or the comment section. Okay, see you in the next class.